Hello students, in this video we will study about the stability of organometallic compounds. Okay, well we will begin now with the topic. So the first concept under the stability of organometallic compound, you have this one, the beta hydrogen transfer mechanism for the decomposition of the metal carbon bond. In this picture, you can see the organometallic compound. Okay, this is an organometallic compound. You can see the bond between the metal and the carbon, right? So this will be our organometallic compound. Okay, and this group can be anything. Okay, it can be methyl, or it can be even a hydrogen also. Okay, and this carbon is attached to the metal, right? So this carbon will be our alpha carbon. Okay, and this carbon is beta. Okay, this carbon is present in the beta position, right? This is alpha, this is beta, and whatever the hydrogen here that is attached to the beta carbon will be the beta hydrogen. Once again, here it can be anything, it can be methyl group or any other group. Okay, but this is our beta hydrogen. Now what happens is that when you have a beta hydrogen in an organometallic compound, there is a high possibility is that this hydrogen is transferred to the metal. Okay, why? Because mh bond, you can see in the in this side, right hand side, there is a formation of mh bond, this metal and this hydrogen, right? So this bond between the metal and hydrogen is very stable than the mc bond. Okay, because of that reason, if you have a beta hydrogen, it readily forms mh bond. Okay, the bond between m and c breaks down and mh bond is formed. And along with this mh bond, you can see there is an elimination of what? This group. What is that? That is an alkene group. Okay, so ಏನಾಗುತ್ತೆ beta hydrogen transfer ಆಗುತ್ತೆ and ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಿ ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಬರುತ್ತೆ, ರೈಟ್? ಯು ಕ್ಯಾನ್ ಸಿ ಹಿಯರ್. ಸೊ ಎಮ್ ಎಚ್ ಬಾಂಡ್ ಆಗುತ್ತೆ, ಹಾಗೆ ಅಲ್ಕಿನ್ ಗೆಟ್ ಎಲಿಮಿನೇಟೆಡ್. ಇದು ಯಾಕಾಗುತ್ತೆ? ಯಾಕಂದ್ರೆ ಎಮ್ ಎಚ್ ಬಾಂಡ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ ಎಮ್ ಸಿ ಬಾಂಡ್. ಓಕೆ, you can read here. If there is a beta hydrogen, the beta hydrogen transfer pathway is available, then organometallic compound will be unstable. Okay, if there is a presence of beta hydrogen, then what happens? This particular organometallic compound will be least stable or unstable. Why? Because it readily decomposes to give mh. Okay, along with the alkene. But if there is no presence of beta hydrogen, okay, if there is no presence of beta hydrogen, then there is no possibility of breakage of mc bond, right? ಇಲ್ಲಿ ಬೀಟಾ ಹೈಡ್ರೋಜನ್ ಇದ್ರೆ ಮಾತ್ರ ಎಮ್ ಎಚ್ ಬಾಂಡ್ ಆಗುತ್ತೆ, ಈ ಎಮ್ ಸಿ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇಲ್ಲದಿದ್ರೆ ದೆನ್ ದಿಸ್ ಕಂಪೌಂಡ್ ರಿಮೇನ್ ಆಸ್ ಸಚ್. Okay, there will be no beta hydrogen transfer or mc bond cleavage ಅಥವಾ ಡಿಕಂಪೋಸಿಷನ್ ಆಗೋದಿಲ್ಲ. Okay, if there is no beta hydrogen, then the organometallic compound will be most stable. If there is a beta hydrogen, then the beta hydrogen transfer take place and mc bond cleavage take place, so that the organometallic compound will be least stable. Okay, I have an example over here. This is the organometallic compound I have taken. In the first compound, here I have written the structure. Here m is a titanium. Okay, here also m is titanium, here also it is titanium. And here in the first organometallic compound, you can see there is a presence of beta hydrogen. Okay, once there is a presence of beta hydrogen, that particular organometallic compound will be unstable. Okay, but in the second compound, you can see that there is a presence of phenyl group, right? That means there is no presence of beta hydrogen. Okay, in this case there was a presence of beta hydrogen, but here there is no presence of beta hydrogen. Once there is no presence of beta hydrogen, then that organometallic will be most stable. Okay, so that is the first point under the stability of organometallic. The next you have the stability to oxidation. Okay, organometallic compound ಯಾವ ರೀತಿ ಸ್ಟೆಬಿಲಿಟಿ ತೋರಿಸುತ್ತೆ ಆಕ್ಸಿಡೇಷನ್ ಮೇಲೆ. Okay, all organometallic compounds are thermodynamically unstable to oxidation. Okay, the organometallic compounds are unstable to oxidation. Okay, there is a space I forgot to give here. Okay, organometallic compounds are unstable towards the oxidation. You can see the reaction here. Mr andre organometallic compound, and O means it is an oxidation. There is an arrow mark here. Okay, so during the oxidation of organometallic compound, you will get metal oxide along with the carbon dioxide gas, and water is formed. Okay, so here what happens is that you can see that the delta G naught and the free energy change for the product side. Okay, the free energy change for the metal oxide, carbon dioxide, and water is negative. We know that delta G negative idre adu spontaneous process. ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಪಾಸಿಟಿವ್ ಇದ್ದರೆ ಅದು ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್, ಕರೆಕ್ಟಾ? ಸೊ ಇಲ್ಲಿ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ ನಿಮಗೆ ಪ್ರಾಡಕ್ಟ್ ಮೆಟಲ್ ಆಕ್ಸೈಡ್, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಆ್ಯಂಡ್ ವಾಟರ್ ಇದೆ. ಅದಕ್ಕೆ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ನೆಗೆಟಿವ್ ಆಗಿರೋದ್ರಿಂದಾಗಿ, ಇಟ್ ಈಸ್ ವೆರಿ ಹೈಲಿ ನೆಗೆಟಿವ್ ಆಗಿರೋದ್ರಿಂದಾಗಿ ದ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನ್ ಈಸ್ ಫೇವರ್ಡ್. Okay, once you have the oxidation of organometallic compound, it readily forms metal oxide. Okay, because of the highly negative delta G naught. Okay, that is the reason why they are highly unstable towards the oxidation. Here, the main group metal methyls are rapidly undergo oxidation. Okay, the main group metal methyls are undergo oxidation. If I give an example, if you have Me2Zn, okay, this is main group metal methyl, and similarly Me3In, Me3In, indium, okay, IN. Again, Me3Sb, Me3Sb is antimony, okay, Sb. All these are very unstable towards the oxidation. Once you expose these organometallic compounds towards the air, okay, just to keep this material under the air, it just burns. Okay, it is very unstable towards the oxidation. Similarly, here many transition metal derivatives, okay, even main group metal methyls as well as transition metal derivatives are also very unstable towards the oxidation. Okay, so what we understood, the organometallic compounds are unstable towards the oxidation, and if there is a presence of beta hydrogen, then it is unstable. If there is no presence of beta hydrogen, then that organometallic compound will be most stable. Then we have this one, last one, okay, the stability to hydrolysis. Here you can see the reaction between the organometallic. Mr means it is an organometallic compound. HOH means some water. The reaction with the water gives the hydroxide, along with there is a presence of RH. Okay. Here, what happens is that in water, I write here, water structure is this one, right? We know that there is a presence of lone pair over the oxygen. So what happens is that the lone pair over the oxygen, that will attacks the metal. Okay, it attacks the metal. Okay, so organic derivative of alkali metal and alkaline earth metal and aluminium group will undergo radiohydrolysis. Okay, if you have the organic derivative of alkali metal, okay, I mean first group element, second group element, and aluminium group ಏನಿದೆ, that will undergo hydrolysis very readily. Okay, because of nucleophilic attack by the water, OH group of the water towards the metal. Okay, so here if the MC bond is more polar, okay, if the MC bond is more polar, then the rate of hydrolysis will be higher. Okay, this can be important for 2 mark. Okay, I'll give the example here. If I have an example, this one, Me3 and aluminium. Me means methyl. Okay, if you have this compound, among these two compounds, which one is which one of these two undergo hydrolysis readily? That may be the question. Okay, so among these two compound, this compound is there, no? will undergo rapid hydrolysis than the first one, because here in the second example, the bond in aluminium and carbon is more polar than the boron and carbon. Okay, because of the uh, you know bond is polar, this compound is can undergo the hydrolysis at much faster rate than this compound. Okay, well, now here the group 14 and 15 alkyl does not undergo hydrolysis, that is they are inert to hydrolysis due to completed octet configuration, and hence nucleophilic attack is not favored. For example, if you have CME4, okay, maybe ameza-methyl, and if you have tetramethylsilane, okay, Si, okay, silicon Me4, and similarly if you have ppH3 triphenylphosphine, okay, I write here ppH3. Now these the compounds do not undergo hydrolysis, okay, because they are inert to hydrolysis. Remember, group 14 and group 15 alkyls are not undergoing hydrolysis due to what is the reason? Once again, this is an important, okay, why they are not undergoing hydrolysis, because they have a completed octet configuration. Okay, they have completed octet configuration, because of that these compounds do not undergo oxidation. Okay, so this is about the stability of a organometallic compound. You have 3 points under this. First one is the beta hydrogen transfer. So what's the beta hydrogen transfer? If there is a presence of beta hydrogen, then organometallic compound is least stable, and if there is no presence of beta hydrogen, that is most stable. And in second point is stability of oxidation. So what we studied, organometallic compounds are unstable to oxidation. Why? Because to the product, in this product the delta G naught is a highly negative ಆಗಿರೋದ್ರಿಂದಾಗಿ product formation favor ಆಗುತ್ತೆ. ಹಾಗಾಗಿ they are least stable towards the oxidation. Okay, and similarly main group metal methyls as well as transition metal derivative are also unstable. The stability to the hydrolysis, they are once again it depends upon the bond. It depends upon the bond. If the bond is more polar, then hydrolysis takes place at much faster rate. If the bond is non-polar, then the hydrolysis doesn't take place. Okay, that means it is stable. Okay, and similarly the group 14 and group 15 does not undergo oxidation, hydrolysis, because of their complete octet structure. Okay, because of that these organometallic compounds are most stable. Okay, so this is the concept.